Hey guys, welcome back to Max TV Original. Today we're going to be making a subscriber counter for YouTube. So far I've been on YouTube and looking at the projects, and they all involve the Max 79 chips and the D1 Wemos Wi-Fi module. However, the code for them doesn't work anymore. I've tried many projects and none of them worked. It always says YouTube error. You probably tried it yourself if you're looking for YouTube counter and you've experienced that problem. So today we'll be exploring two ways of making it. So the first one is very simple. So the video will be in three parts. The first part is this counter, the second part we'll make our own, and the third part would be all about the code. So let's have a look at it. It's very simple. All you need to get is this Max 79 displays, which you probably already have. It's a very simple display. It's got clock, load, data in, ground, and 5 volts in. 5 pins, and then the Wemos, which has got a few pins. So with my code, all you'll need to do is connect VCC to 5 volts to Wemos, ground to ground, obviously, data in to D7, chip select load to D8, and clock to D5. Then upload the code using USB and you're ready to go. And let me show you. So I'll just plug the USB power in. So that bouncy ball is just telling us that it's loading. When it freezes, that means it's getting the subscribers, so it's connecting to Wi-Fi at the moment. Then you'll see it stop. There we go. So now it's getting the subscriber count and logging into YouTube. And there we have it. So it takes about maybe 15-20 seconds to load since it freezes. So when it freezes, don't freak out. It's actually normal. And as you can see, I've got 443 subscribers at the moment. Slowly getting there, slowly getting them. And it works no problem. So again, the thing is that display is very small. As you can see, it fits in my hand. If you're king for that little display, then and you want a simple project, then that's pretty much it. You can skip the next part of the video straight to the coding, where I explain how to program it. Thanks to David, by the way, for helping me with the code. Well, pretty much doing the whole code. But we're going to be making a larger screen. So I've got those panels. As you can see, they're significantly bigger. That's just one of them, and we'll use 4. Those are red, green, yellow panels. So you can choice of color. This was a single color. And the other difference is the Max 7219, actually 72, not 79, I've been saying 70. So they are actually common cathode displays drivers. So they're supposed to drive 7-segment displays, but of course you can drive 8x8 dot matrix displays, which is those, and they're common cathode. This one is common anode. I've got literally tons of those. And plus it's multicolor, so it's got heaps more pins. So let me show you. I'll just unplug this. So if I pull one of those out, you can see there's only, 16 pins. This one however, has got a lot more pins than 16. And it's common anode. You still can drive, you don't need to build an inverter with the transistors or anything. You still can drive this directly from that Max 7219 chip. The secret is you invert it, so whatever's supposed to go to anode, you could connect to cathode, and all the cathode you connect to anode. The trick then to flip display, so usually if, imagine this is the digits here, this is the way you'd be displaying it, but if you reverse it, the screen would have to be turned 90 degrees that way, and that will make a line, and that works fine. So other thing, because it's dual color, red and green, the pinouts in this one, they are very odd. They're not really, I would say logical. So this tells you the columns and rows. So for example, for column 1, it's pin 5, 6, 7, 8, 9, 16, 15, 14, 13. And for the rows, it goes pin 1, 2, 3, 4, 12, 11, 10, 9. So, a bit funny. With this one, unfortunately, I couldn't find the data sheet, but I know the pin outs. And they are going to be, if we're looking at pin 1 here, so we've got pins, and they are numbered in sections. So this would be 1, That would be 2, 3, 4, and so on. All the squares that I've drawn, that's a common anode. So I'll leave them blank. And the round ones, it's going to go a red and green, red and green, red and green, and so on. So if I want to light, for example, a pixel on row 5, pixel 6, it would be easy. I would go row 5, which is those ones, so 1, 2, 3, 4, 5, so I would connect positive here, and pixel 6, depending on whether red or green. If I want to light up red, it'd be this one. If it's this one. So it's very logical. So those numbers represent rows and columns. So again, if I want to light up row 4, column 8, I would connect row 4 to positive and column 8 to either green or red, whichever one, or both of them for yellow. So this one is a bit more confusing than that. So I would have to design mine. And the way I've designed it, obviously it's going to be on 90 degrees, so the pins are going to be sideways like that. And what I've done is, when I wire it, so we've got 2 circle ones and a square for, say, number 1. You can wire it like that to go to the chip. But also, if you want to switch the color, all you have to do is just simply wire it this way instead of that way. And you'll get the green or red, or if you wire both of them, you'll get yellow. So you can simply choose. You don't need to redo the schematic ones. The other way of doing it, if you're building, you can have, so that's your 3 pins, and you can have something simple like that, and you have a pad here, then you have a pad here, and you have a pad here, and then with a blob of solder you can simply short out those 2 pins, and you'll get one color, or short out both pins and you'll get yellow. So like a little solder switch. So you just put a drop of solder on it to select. I'll be designing for the green one, so mine are directly going in. So that's pretty much all explained. And I like the big displays, of course, better than those. You can see the size difference. Like, you can fit 2 of those little displays in the place of 1. You can probably put 4 of them in. So those are very common. They're usually from the displays that run, what is it, 16 by 32. I think I've got one somewhere laying around here. I've got actually board for it. It's those displays, which I will be covering in a later video. They are very popular as well on eBay. So now let's have a look at the circuit board. Here is the completed board that I have designed. I haven't trimmed it properly, so you can see there's a bit of a rough edge. I'll upload, if you're interested in this board, I'll upload the design just in the description below. So this little cutout is not meant to be there. Actually, I've had to cut it out because I've put that really flat, as you can see with board itself. You can just lift it up a bit, and that was already pre-programmed with the software, but then I needed to change it around a bit, so I had to cut that off to fit the plug. That's all working, so I've programmed it. It's a very simple design, so not many components at all. I've added the Max 7219 chips. They all have 5K resistor for the current limiting of the displays. It's recommended 10Ks, and I've put 10Ks, it wasn't as bright, so I've doubled it, which made it half, so there's 2 10Ks resistors in there. And that's made it a lot brighter to the standard brightness. That's it in the front, and obviously just a module soldered on. In the back of it, we've got just 4 decoupling capacitors on the power line, and that's it. I didn't want to do a solder resist on that board. It would have been really messy and a long thing, and so I just left it off with a liquid tin on, because that should be protective enough. So now all I have to do is just pop the modules on, and that would be a fairly easy task. I've inserted all the panels in. I've also soldered a little antenna from a laptop that will, that I'm planning to put it in a aluminium enclosure, and it will happen that the frame itself will actually go over this part. So you don't want, aluminium to interfere with the signal. So I've attached a little antenna from laptop, just soldered it onto, onto the track here. And that'll stick on the plastic on the back, or, maybe in the front of a glass here, something like that. Then I've also added a little external power supply, because I won't be powering it from the USB. The USB in here is only going to be for programming. Even though you can power it, I'll just use it for programming if I ever need to. So I've just going to have this, and I might actually add a little buck converter, from 12 volts to 5, or voltage regulator, just so I can plug it into normal power supply, like 12-volt power supply. So this is done. Let's plug it in and have a look. So we've got the bouncy ball. I'll turn the light off so you can see. And here we have it, 446. So it probably not the best view because I've got the lights on it. But if you add a piece of paper or the glass on it, yeah, it would be better. Probably tissue as well, if the tissue will work. So yeah, once it'll have diffused glass over the top, it'll be heaps better, as you can see. Because at the moment you can see the white dots on the background, and it's especially visible on a camera significantly, so it's hard to tell. But once you have the glass again, it's going to be fine. So that's the bigger version of that subscriber count. Again, you could use a smaller panel, but I prefer the big one. So that's it for the hardware. Now let's check out the software. Let's talk about the firmware. So once you download the file in the description below from Google Drive, here's what you're going to find inside. One folder that will say the subs counter, and it'll have the Arduino file and 2 other files for the Max72 and MD Palora, and the text file. In the text file there's a link for where to get the libraries from. Don't click it, I'll tell you what to do with it in a second. So let's have a look at the code itself. So here is the file for Arduino. Once you open it, in line 12, that's where you're going to be entering your Wi-Fi. So replace whatever the Wi-Fi here is, which is my Wi-Fi, with your Wi-Fi network name. As you can see, I've set it here. By the way, thanks David for helping out with the code. Well, pretty much doing most of it. Then you're going to enter in line 13 your Wi-Fi password. So replace 123456789 with your Wi-Fi password. Then in the 14th line is your API key. To get the API key, it's actually very simple, probably take you 5 minutes. You go to your Google, or you can just Google how to get API key, and there'll be a link. You'll open the developers, I think, page or something on Google. You register there, create a YouTube API key. There's plenty of videos and info on how to get your API key for your channel. Once you do that, you paste it here, and then your line 15 is your channel ID, which is very easy to get. Simply open your YouTube channel, and at the top here, as you can see where your address line is, I'll show you. So this is obviously my channel. So you see the address, it says youtube.com channel, and then from that /, the last numbers that I've highlighted here is your YouTube channel ID. So just from the home page, don't click any videos. As soon as you go to your channel, those last numbers is your channel ID. So you can copy that and paste it there. As you can see, it matches the code. There we go. So it matches here. So that's all you will need to set it up. Now there's another quick thing. If you actually using that small display that you can buy on eBay or anything, then scroll down to line 46, and I've already left it there. As you can see, it says the hardware type. Let me just find where it is. There we go. So you can see it says hardware type MD Max, and then it says FC16_HW. That's for the standard display that you buy on eBay, that Max7219. However, if you are using my files that I've included with the circuit board that I've done for the bigger displays, you will have to replace it with a different number. You will have to type in DR1 as you can see here, CR0RR1_HW. So just type that instead of the FC underscore. And that will then work with my display that I've designed. So how to get those libraries? Once you're in the Arduino, you will need to click to File and Preferences. In Preferences, there's a line down here where it says Additional Board Manager URLs. That's where you place that URL that I've included in the text file. So place it and click OK. Then you will click Sketch at the top. You'll go Include Library, Manage Libraries. Once the Library Manager opens, you will take any of those libraries that's at the top. So say YouTube API.h. You will copy that in advance. Hang on, sorry, it's updating libraries. So you will copy that YouTube API.h, paste it in here, and click search, and it'll come up, and then you'll just install it. Same with the next one, like ESP8266 Wi-Fi.h. You copy that and you paste it here, and if it's not installed, you'll click install and install it. So make sure you got all of those libraries here. Copy them into search panel, search and install. So once you've installed all this, you'll have no problem assembling the file. So I think that's pretty much it with assembling the file. And then yeah, just select your board, which is Tools, and you will select a board which will be LOL in. Let me just zoom in so you can see. You select LOL in brackets WeMOS, D1, R2 and Mini. That's if you get the Mini one. You select that and leave the rest as is. Select your COM port and that's it, and you're ready to go. So that's it on the code. If you do have any questions, I'm happy to answer them. Don't forget to comment. By the way, just a quick heads up, I've noticed YouTube has been deleting a lot of comments. I've had people asking me for help, going, hey, I've got a problem with the projector, what should I do? It comes up in my notification. I click on the all I can see is a header. I click on it and it says 0 comments, and it's just disappeared. So a few times I assumed that person deleted their own comment, and then one person says, oh, you've been really rude, you've deleted my comment, I've been asking you for help and you just deleted, that's really rude. And just wanted you to know that I don't delete comments at all. So if you post the comment and then you notice that it's not there, just post it again. Try to rephrase it, because it's YouTube artificial intelligence that deletes it for no reason, even if it's not rude. I don't know why they're doing that, but yeah, don't delete comments. So here's the display installed in the enclosure, which I've built out of aluminium, and I've had the glass, which is a perspex glass here, that I've laminated with window tint to give it a bit of a, you don't want to look at this specifically. So what I've done is I've stuck the antenna on the edge of the glass here, which is just so it's not over the aluminium, it's just over the open space there, and it's just where the screen ends, so it's not on the way either. I've also added a 5-volt voltage regulator here, so that it's got a variety of voltages in, I think from 35 or something volts or 40 volts to anywhere to 5, obviously, wide range. So this top is removable. There's 4 screws that on the edges here that can be removed, and then the top comes off. That's in case if I need to plug it in and reprogram it for whatever reason. But if not, they stay on, and just there's a power in the back, so I'll show you. That's the glass that goes over the top like that. This is screws here, so this part is stapled here, and those screws are actually screws themselves. And in the back here we just got the aluminium, and I'll clean it up, and that's the wide range power input. So I'm just going to put this together and I'll show you this display and the smaller one. So here are the displays ready to go. That's the little one that I did. It is powered from USB. So here is the USB power there, and it's also used to program as well. So it's a power and programming. That's the little one. I'll plug it in and we'll let it boot. So while that's booting, that's the big one. all in enclosure now, so same thing, just 24 volts or 5 volts, 12 volts, any voltage here. So that's all ready to go as well. So I'll plug this one in and let it boot as well. And I'll turn the light off so you can see better. So here is the little one, is on. And here is the big one, is on now. So you can see that smaller one that you buy on eBay is very, very small. This is a large one, and it's really vivid, you can say that. So this, I guess, will go onto my workbench, and this one probably will go into my bedroom. That's it on those YouTube subscriber counters. I hope you enjoyed this video. Thanks for watching. If you have any questions, feel free to comment and like the video. Don't forget to subscribe as well, so this keeps going up. Thanks for watching. See you next time. Bye.